This is part 2 of the Ceph Mimic installation. In the previous section we configured OSDs and we configured a Rados pool. Today we're going to look at how to configure CephFS, configure a Rados gateway and also the Rados block device. In this section we're going to create a CephFS pool. First of all, we're going to get rid of an existing pool that we configured from part 1 called test pool. However, with Luminous you have to explicitly set in a command to allow the pool deletion. This can either be done in ceph.conf or it can be done in the command that I'm doing here. So this is an argument that we can dynamically inject to the system. So now we'll delete the pool that we have. So to delete a pool you have to specify the pool name twice and pass -- yes I - really - ready - mean - it. So we'll do that. Okay, so now if we do Ceph OSD ls pools, we should see that there are no more pools. Alright, so what we're going to do is we're going to create two pools. We're going to create a metadata pool which is needed for CephFS, and we're going to create a regular data pool. So we'll do Ceph OSD pool create CephFS meta pool, and we'll give it a PG of 128 and we'll use the default replication pool. Now we're going to create a second pool. This time it will be the data pool. So now if we do Ceph OSD ls pools, you should see the two pools. There they are. The next thing we need to do is to create a metadata server. In this small cluster we're going to use the mon node to act as the metadata server. Typically this will be done on a dedicated node. In fact, there will be more than one node for redundancy, but for our case we'll just use the mon node. So the command is ceph-deploy mds create and then the node name that you want to use, which in our case will be 100. So you can see a little bit of activity going on there, and that's created that. So now that we've created the two of these, we can create a file system. So the command is CephFS new, whatever the file name is for the file system. So we're going to call it my CephFS, and then we need to specify the metadata pool and the data pool. So CephFS meta pool and CephFS data pool. So create a new FS, that's the message there we've got. And again, there's a little bit of activity. You can see up in the top watch window, the metadata server, my CephFS is up and all's looking good there. So we can also do Ceph MDS stat just to get a look at the statistics. And again, that's similar to what you saw up above there as well. Now that the file system has been created, we want to interact with it. So the first thing we'll do is we'll create a mount point. So sudo /CephFS. Okay. And then this command will mount it on that mount point. So you can see what we're doing is sudo mount -type is Ceph, then the monitor node. Then we're going to mount it on mount /CephFS, and the default name here is admin, and you can see that the secret will be the output really of the Ceph auth tool, which prints out etc/ceph/ceph.client.admin.keyring. You could actually put in the keyring yourself if you wanted, but that's not really considered good practice, because what you're doing is you're sending out the secret in plain text, so that's not really a good thing. You can see that back in the history command. Alright, so that should go ahead and mount. Alright, let's just look at that. Mount. And you can see down here 10.10.100.6789, and there we go. So let's see if we can copy some files. So there's a few here where we are. So sudo cup star to /lnt/CephFS. Okay, and now let's have a look at /lnt/CephFS, and there's the files there as well. Before starting the next activity, we'll bring back up the dashboard. You can see the two new pools there, CephFS meta pool and the data pool. Actually, if we look at the file systems now, you can see there's a file system, my CephFS. There it is there. You can see the data pools. You can actually see that the data pool has a lot more usage than the metadata pool, which is exactly what we'd expect. So let's start some activity. We'll use the dd command. So here we're going to run some IO. We're going to fill it with a bunch of random numbers onto the file system. We're going to use a block size of 16K, which you can see there, and that's our count, which is 100,000. So let's hit enter and see what happens. We should start seeing some activity here on the system. So let's go to the dashboard first of all. Alright, you can actually see, so there's some activity going on there. On the client side, we can look at the pools. Let's look here at the cluster. Let's see what's going on with the OSDs. So there's the activity. Again, we're doing right, so that's fine. File systems, let's have a look at that. You can see some activity here is going on as well, but it's sending in a request. So we can actually hover over that. You can see more information about the number of inodes that are open. It's all the activity there. Let's see what's happening with our pools. There's the total, not too much to see on that side. On the file systems we've just been to. And let's see what sort of activity is going on with the monitor. Recall that the monitor is actually using the it's also working as the metadata server as well. So you can see there's some activity going on there. Alright, just back to the dashboard. So we've gone up here, 422 objects, 8% raw capacity. So we've used around 10 gigabytes. It's still working away. 3% usage, and there we go. So you can see how much CPU it did in around 15.3 megabytes a second. So next thing we'll do is we'll run a benchmark. One fairly popular benchmark is Bonnie++. So we need to install that. So sudo yum install yes Bonnie++. So you should find that in the default repositories, and indeed it has. So this will take a few moments. Alright, so when we run Bonnie, we should typically use twice the amount of memory, so we want to avoid things like caching. So you can see the command we've issued there is Bonnie++. We've given it the location. We're giving it 8 gigs, which is twice the memory. We also have to put in the user root. So this will go along here. It'll run a number of different tests as well. We should again be able to see some sort of activity going on here. Let's have a look at the OSDs, and you can actually see, depending on the phases, it's doing reads and writes and various things like that as well. And you can see a reasonable amount of activity with CephFS. So Bonnie++ does a number of different things. It does large writes. It even writes a byte at a time, which is not going to give you very good throughput. So you can see later on it'll give you a good idea of the output of this system. So again, this will take a few minutes. So right, we widened out the terminals just to make it a little bit clearer. So the Bonnie++ program is completed. You can see a lot of data here. A little bit hard to read, but this is really the camera separator values of everything that's been put out. Now luckily there's a utility which will pass this information and put it into a much easier read format. So this utility is called Bond2HTML. So what we really need to do is to highlight all this information. So we've opened up another window, and I've actually put in this results before. So what we need to do is use the command echo, open up our quotes, and these values here are simply the pasted values from down below here. So we need to paste up to there. Then once we paste that, we close our quotes, pipe it into the utility bond_CSV to HTML. So this basically converts CSV, comma separated values into HTML, and then redirects that into a file called results.html. So we'll do that. And then what we can do is just simply load up a browser to display our results. So we'll use Firefox for that, and you can actually see there's a lot more information here. There's the host name. You can look at latencies. You can look at the character performance. You can look at the block performance. You can look at various things like seek. So this is a very useful tool. In this section, we're going to create an RBD device. So the first step is to create a pool for the RBDs. So we'll create this RBD pool with 128 placement groups. All right, Ceph OSD LS pools, and you can also see that the pool is up there as well. The next thing we need to do is to create an image. So this command is RBD for Raiders block device, -P for the pool name, which is RBD pool, and we're going to call it RBD image, and we'll give it a fairly small size of somewhere around 10 gigs or so. Alright, so the image is now created. If we do the command RBD ls RBD pool, you can see the image there in the pool. Now, depending on the kernel, not all the features will be enabled. So here we're going to disable some of the features. You'll need to check this to see which features are actually supported and which ones aren't. Alright, now that that's done, we can do sudo rbd mop rbd pull / rbd image. Okay, and now it's come up with /dev /rbd0. If we do lsblk, we can see the device down here at 10 gig, which was the size that we gave it. We can do other commands like rbd show mapped. We can see it's got an ID of 0. The pool that it belongs to is rbd pool. The image is rdb image, and the device is /dev /rbd0. We can also do a command rbd --image image name, the pool name, info. So we can see the features that are enabled, which was disabled. You can see the size, you can also see some of the other features as well with the system. So now we're going to format the device as normal. So mkfs, we'll make it xfs /dev /rbd0. Let's create a mount point. And let's mount the device. Okay, so that's mounted there. Now the next thing we can do is run some benchmark testing on it. Alright, so next thing we can do is we can run an FIO benchmark on the system. If you don't have FIO installed, it's simply a matter of doing yum install FIO. So let's bring this up. I already typed this in earlier, so there's a few things you notice here. The file name, this is on the device itself rather than any particular folder. Direct equals 1. We'll do a random write operation, block size of 4K, number of jobs. You can also see we've got an output file as well. So let's hit enter to start that. So here's the job running. There's also a little bit of activity up here on top. We're running a fairly small block size, so I don't expect stellar performance in any way, shape or form. Alright, now that that's finished, we can have a look at the output file. So cat rbd0.out, and you can see some of the FIO results here. You can see the bandwidth and a few other parameters if you're interested. So far we've looked at CephFS, we've ran some benchmarks on that. We've also created a Rados block device, and we ran the FIO benchmark. The next thing we're going to do is configure the Rados gateway, and what we'll do is we'll testing the Rados gateway using a utility called cosbench. I'm not going to go into any detail about how to configure and set up CostBench, as there's a bit of work to be involved, but I've actually pre-installed it here. So I will show it working through the Raiders gateway and how we can test the functionality. So the first thing we need to do is to set up the gateway. So we do ceph-deploy or GW for Raiders gateway. The operation is create, and we're going to use our overworked mon node. Alright, so you can see the activity going on. There it is, and that's working here. So the next step we need to do is we have to create some user information. So this is a fairly long command. ray-gw for Raiders gateway -admin user create --uid equals Ceph user, and the key type will be S3 for Amazon, which Ceph has got compatibility with. We need to set up an access key. And then a secret key. And we need to specify the name that will be displayed. Display -name equals, in quotes, Ceph user. Let's just verify that. Okay, so we'll do that. So you'll see some information here. Some of this is quite useful as well. So display name, which we said, we didn't specify anything like emails, but you can get into that level as well of detail. You can see the access key and the secret key here as well. Things like bucket quotas and various other facilities. Now, if we open up a browser and we put in the Raiders gateway node name with port 7480 and hit enter, you should get this sort of output. So this gives you basic confidence that the system has been set up correctly. If we look at the pools, so we do Ceph OSD ls pools, you can actually see a number of pools being set up for the Raiders gateway. So without us doing anything, these pools were all created as well. This is our previous RBD pool, which we used for the RBD block devices, and this has now been created. We can open the CostBench web interface by going to the monitor node, giving it that port number, and then onto controller. We need to submit new workloads, and I've actually written one here which does 1 meg writes. So we can open up that program and we'll do submit, and you can see there it says processing, so there's some activity going on. It does some initialization, and then what will happen is it will start doing the actual write benchmark itself. So we can do view details here, see what's going on. So that stage is completed, which is the initialization stage, and now what's happening is the system is running. So if we look at that, you can actually see on the throughput graph this gets refreshed fairly regularly, and this is the ratio of reads to writes. This is the bandwidth that we're coming along, and you can see the kind of performance we're getting with the operations per second. So that's the Rados gateway. This will be used typically in conjunction with something like Amazon, but for our purposes we can use the CosBench program to test that everything is fully functional. So if we go back to our Ceph dashboard, we can see that we have the various pools that we created, and we spoke about them earlier. So these are all the Rados gateway pools. You can actually see that the placement group is very small for the pools. This is something that really you may have to go in and adjust later on, but these are the default values that you get. If we look at cluster and then we go to hosts, you can see that our Mon node is functioning as a manager, as a monitor, and now also as a Rados gateway. So if we click on that, we get a bit more information here about some of the various pages as well. So that's really a roundup of the Rados gateway function within Ceph. This concludes the second part of the Ceph Mimic tutorial. The third and final part will go into some more of the commands, and we'll look what's going on behind the scenes in a bit more detail. So thanks for watching.